evening,
Good evening,
students.
sir.
Good evening, students. So, today we are going to discuss the friction force. So, first question is, what is friction force? Basically, friction force is a dissipative force. Is a dissipative force. Dissipative force means energy is lost. ठीक है ना, due to the friction. What is the meaning of dissipative force? Means energy will be lost.
हेलो स्टूडेंट्स, आवाज आ रही क्या?
Hello, am I audible?
Yes, sir.
Okay. So basically dissipative force means energy will be lost. Energy will be lost due to friction. Energy will be lost due to friction. And when this friction comes into the picture, when this friction is going to be in the picture, basically when there is relative motion. When there is relative motion between two surfaces. Motion between two surfaces. Two surfaces here. So what I'm saying, suppose this is a block here I placed on this surface. So there is a block that I have placed here. Okay? And suppose this block is moving in this direction. This block is moving in this direction with some velocity. So basically with respect to the ground surface, this block is moving. So due to the relative motion between this lower surface, try to understand, due to the relative motion between the lower surface of this block and the upper surface of the ground. So there is a relative motion between the ground surface and this lower surface of the block. So due to the relative motion between them, basically a opposing force, resistive force will act in this direction. So in this direction, a resistive force is going to act. That is going to oppose this relative motion. So this friction force always opposes the relative motion. So this relative motion is opposed by the friction force. Opposed by the friction force. So basically, what I am saying here, if there is a relative motion between two surfaces, then a force in the opposite direction to the motion is going to act. ठीक है, that is dissipative force, and this is going to oppose the relative motion. ठीक है, that is going to oppose the relative motion. So try to understand here one thing, that this block with respect to the ground, it is moving in this direction. So on this block, this friction force is going to act in this direction. While, ठीक है, on the earth surface, friction force is going to act in this direction. So basically here, due to this relative motion in between two surfaces, on one surface, friction force is going to act in one direction, but on the other surface that is in contact, it is going to act in the opposite direction. So on the block, this is the friction force. On the earth, this is the friction force. So due to the relative motion between two surfaces, there is an opposing force that is going to act. That is called as friction force. That is called as friction force. Why this friction force is coming into the picture? If you look at the microstructure, try to understand. If this is the ground surface and you look at the microstructure, what you are going to find out, that lower surface of this block is like this. Okay? And for the upper surface of the ground, that is also having microstructures like this. Troughs and crusts. So these surfaces on the upper, from our normal looks, basically they appear as smooth. But if you look at microscopic structure, there are troughs and crests and crests. So there will be interlocking between this. So in this region, there will be interlocking. There will be interlocking. So when this block try to move in this direction, this interlocking, the block has to overcome this interlocking, and this interlocking is causing a force that is acting in the opposite direction on this block. This is called as friction force. This is called as friction force. So whenever there is a relative motion between two surfaces in contact, then there is an opposing force that is acting, and that is called as friction force. In this friction force, energy is always lost. So basically energy is lost, okay, when friction is acting. That's why you are going to call that friction force is a dissipative force. So this is the definition of the friction force. Next question is, in general friction force, ठीक है ना, mainly two or three types of friction forces are there, and first type of friction force is static friction. Static friction. What is the meaning of static friction? Static friction. So if this is the lower surface, ground surface, and block is here, block is here, ठीक है ना, where, and in case of static friction, what is going to happen? You are applying a force on it. But even after application of the force is applied, but still this block is not moving. ठीक है? Force, even after the application of the force, even after applying the force, there is no relative motion between them. There is no relative motion between them, even after applying this force. In this case, on this block, in this direction, there is a friction force that is acting, and it is called as static friction force. So static friction comes into the picture when even after applying the force, there is no relative motion between two surfaces. Then a force that that is opposing, that is, this friction force is opposing the expected motion. Motion is not taking place, relative motion is not taking place, but this was expected because force is applied on it. So this friction force is coming into the picture so that expected motion cannot take place. So that this expected motion cannot take place. So when when there is no relative motion, when there is no relative motion, when there is no relative motion between between two surfaces in contact, between two surfaces in contact, in contact, even after applying the force, even after applying the force, even after applying the force, then the resistive motion, then resistive motion, then resistive motion, yeah, resistive force, then resistive force acting between two surfaces, between two surfaces is called is called static friction, is called static friction force, is called static friction force. So what is here, basically in this case, actually in even after application of the force, There is no relative motion. There is no, you are applying the force, but relative motion is not taking place. Why this relative motion is not taking place? Question is, so that relative motion is not taking place because a resistive force, a resistive frictional force in the opposite direction of the expected motion comes into the picture. That comes into the picture. And that due to this static friction force, this resistive force, this motion is not taking place. So this force is called as static friction force. And what is important about this static friction force? What is important about this? This is self-adjusting force. What is this? Most important part is self-adjusting force. This is self-adjusting force. ठीक है? So another important aspect about the static friction force is this is self-adjusting. So you are continuously you are applying the force, but block is not moving. So that is due to this opposing force, opposing resistive force that is called as static. And most important aspect is this is self-adjusting. This is a self-adjusting force. What is the meaning of self-adjusting? To understand self-adjusting force, first we have to understand this, this. Suppose this is a block, its weight is going to act in the downward direction, its weight is mg. So a normal reaction is going to act on it, that is n. Now you are applying a force on it, force on it. Okay. What I do, I apply a force of 1 Newton. I apply a force of 1 Newton. Then opposing whatever motion was expected due to the application of 1 Newton force. Basically, motion was expected, but motion is not taking place. Why? Because on this block, a friction force is acting in the opposite direction, opposite to the expected motion. And what will be the magnitude of this Fs? That will be exactly 1 Newton. So when you are applying a force of 1 Newton, then the magnitude of this static friction force will be 1 Newton, and this block is not going to move. Applied force will be exactly equal to the static friction force. Static friction force is exactly balancing this force of 1 Newton. So that's why net force in the horizontal direction will be 0 and no motion will take place. Now what you do? You have increased this force. What you have done here, you have increased it to 2 Newton. Then what you are going to observe, that static friction force will also increase its magnitude so that no motion will take place. Now static friction force will become 2 Newton. 2 Newton. You further increase it, you make it 3 Newton. 3 Newton. And you will find out that static friction force also increases to 3 Newton and no relative motion is taking place. So this process will go on unless and until you apply a particular value of the force. Okay. So this process, if you increase the force, you will find out that static friction force will increase. But there will be a particular value of the force after the application of which this block will start moving. Okay. So there will be a maximum value of static friction force. So maximum static force, maximum static friction force will be there. Static friction force will be there. Force that is written as Fs, static friction force, maximum value of this. And this will be equal to mu s into n. What is mu s? Mu s is coefficient of static friction. This is called as coefficient of static friction. Static friction. So what I'm saying, if this applied force becomes greater than this static friction force, is maximum static friction force, in that case, this block will start moving. This block is going to, it will start moving. If you apply a force that is greater than this. So for motion of the block, for starting the motion, for for starting the motion, the motion, this force, applied force, that should be greater than this maximum value of static friction force. So if F becomes greater than this mu s and this is n, in that case, this block will start moving. For example, in this case, if I choose m equal to suppose 20 किलोग्राम, ठीक है, और g I consider 10, ठीक है ना, 10 meter per second square, I call it as 2. Rather than 20, I am writing it as 2 kilogram. G is this. Mu s, I'm saying coefficient of static friction is 0.5. 0.5. So what will be the value of Fs max? Maximum value of static friction force, that will be mu into n. What will be n here? From here, n will be equal to mg. So this will be mu s into mg. This will be 0.5 into 2 into 10. So that will be 10 Newton. 10 Newton. So this is the value of maximum static friction force. Maximum static friction force is 10 Newton. Is 10 Newton. So here I am making the table applied force. This is applied force. Okay? This is applied force, and here I'm writing Fs, static friction force. So if you apply 1 Newton force, then static friction force will be 1 Newton. If you are applying 3 Newton, it will become 3 Newton. If you apply 5 Newton, then you will find out 5 Newton. If you apply 8 Newton force, then static friction will be 8 Newton force. If you apply 10 Newton force, then static friction force will become 10 Newton. But this is the value of Fs max. So when you are applying Fs maximum 10 Newton force, in this situation, this block is ready to move. So whenever you apply this, now this block is ready to move. Now this block is ready to move. Is ready to move. Block is ready to move. Now you apply a force greater than this 10 Newton. So suppose you apply 1 Newton, 11 Newton. And what will happen? This static friction force, this will convert into kinetic friction force. And block will move. Here, ठीक है ना, in this case, this static friction force, it will convert into kinetic friction force and block will start moving. So now, in this case, what will happen? Block will start moving. Block will move. Will move. And static friction force, it will convert. So this static friction force, that is going to convert into kinetic friction force. Now when block is moving, then friction force will be of different type, that is called as kinetic friction force. Kinetic friction force. So basically this is the meaning of self-adjusting. Means value of static friction force is going to change with the applied force up to Fs maximum value of static friction force. There is some maximum value of static friction force, that is mu s into n. If you are applying a force less than this, then static friction force will be sufficient to stop this motion. This static friction force will not let this block move. This block is not going to move because this static friction force is sufficient so that motion is not going to take place. But if applied force becomes greater than this maximum value of static friction force, then block will start moving. However, then this static friction force, it is going to convert into kinetic friction force. ठीक है ना, that is going to convert into kinetic friction force. So this is static friction force. This is static friction force. So what I am saying here, if I draw a graph, try to understand. If I draw a graph of applied force here, F force I am writing here. This is applied force. And here, this is friction force. Friction force. Then you are going to observe that as you are increasing F, it is going to increase. So here in this range, this is 45 degree, Fs is equal to F, applied force. And it will increase up to which value? It is going to increase up to a maximum value of this static friction force. So here, this is Fs max. So this type of graph you are going to observe up to maximum value of static friction force. After this point, if you further increase this force, then this block is going to move. This block will start moving. This block will start moving. So what is this called as? Static friction. This part of friction is called as static friction. Static friction. Okay? Next. I will complete this graph after a little while. Next is kinetic friction. Next is kinetic friction. Okay? What is the meaning of kinetic friction? When block is moving, even in that case, a resistive force, a opposing force is existing between two surfaces. It is trying to stop. It is opposing the relative motion between the two surfaces. This is called as kinetic friction force. So when there is relative motion taking place between two surfaces in contact, then the opposing force, okay, that is acting on these two surfaces, that is called as kinetic friction force. So when motion is taking place, suppose this block is moving, this block is moving, okay, due to the application of this force. Motion is taking place between the lower surface of this block and upper surface of this surface, upper surface of the ground surface, then an opposing force. Block is moving in this direction. So on the block, this friction, kinetic friction will act on this block in this direction. ठीक है ना? This kinetic friction force on the block is going to act on this direction. But if you look at the earth, ठीक है ना? With respect to this block, earth is moving in this direction. So on the earth, same equal and opposite kinetic friction force is going to act, ठीक है ना, in this direction. ठीक है ना? This is a internal force and net internal forces are zero. So that's why they are equal and opposite. If you look at the complete system, net force acting on the system is zero, internal force. So on the block, if you look at the block, when it is moving, ठीक है, in this direction this block is moving, whatever force is acting over it, so I can call, suppose some force is acting on it and it is moving due to the application of the force. In this direction, a kinetic friction force is acting on it. Mass of this is m. Mass of this is m. So what is going to happen? How much net force in this direction is acting? That is F minus Fk. This mass into acceleration. That is mass into acceleration. ठीक है. Apart from this, this is weight mg, and this is acting. This is n. This is n. ठीक है ना? So F minus Fk, that will be this. This will be this. So what will be the acceleration of the block here? That is F minus Fk divided by m, divided by m. So this will be the acceleration of this block. This will be the acceleration of the block, like this. And what will the value of this kinetic friction force? Kinetic friction force, that will be equal to mu k into n. N is normal reaction, and this is called as coefficient of kinetic friction. This is called as coefficient of kinetic friction. This is called as coefficient of kinetic friction. So if you apply a force over it, even I can write a force in place of V. This is F. This is, so this will be the acceleration. So when kinetic friction comes into the picture, so basically when there is relative motion, when there is relative motion, when there is relative motion, when there is relative motion between two surfaces in contact, two surfaces in contact, then opposing force, opposing force, ठीक है ना, acting is called kinetic friction force. Kinetic friction force. Kinetic friction force. Always remember, friction forces, they are always going to act along the surface of contact. ठीक है ना? Along the contact surface. Friction force will always be parallel to the contact surfaces. Even you can write here. Even you can write here. So here. So this friction force, ठीक है, whatever this friction force is, so friction force always act along the surface of contact. Yeah, along the surface in contact. Surfaces in contact. In contact. ठीक है ना? That's why you also call it as contact force. ठीक है? This is an example of the contact force. So now here in this case, here this was the maximum value, 10 Newton was the maximum value of static friction force. Now suppose you apply here, what you do, now you are applying a 11 Newton force. So I'm providing you here mu k. Mu k is suppose 0.4. Mu k will be equal to 0.4. ठीक है, म्यू के will be equal to 0.4. Now suppose this is 0.4 and you have applied how much force? 11 Newton. How much force you have to apply? You have applied, that is 11 Newton. 11 Newton, because this 11 Newton is greater than this Fs max. So here this is greater than Fs max here. Maximum value of static friction force was 10 and it is greater than that 10 Newton Fs maximum. So this block will start moving. What will happen here? Block will start moving in this case. So in this case, this block will start moving. Because now block is moving, so this force now, ठीक है ना, this will be now kinetic force. So it is converted from Fs to Fk. When block starts moving, this Fs static friction force will convert into Fk. What will be the value of Fk? Fk, that will be mu k into n. That will be equal to mu k into mg. Mu k is 0.4. M is how much? 2? 2 into 10. So this will be 8. 8 Newton. 8 Newton. So how much, what is the value of this opposing force? That is 8 Newton. So 11 Newton you are applying and opposing force is 8 Newton. So what will be the acceleration here? Acceleration will be this 11 and opposing force is 8 divided by mass, that is 2. So this will be 3 by 2. So 1.5 meter per second square. ठीक है ना, this will be the acceleration. So with this acceleration it is going to move. ठीक है ना, this will be 8 Newton here. This is 8 Newton. Block is moving, kinetic friction is there, and acceleration in this case here, acceleration comes out to be 1.5 meter per second square. Here in this case, up to this block is at rest. Block was at rest. But after this Fs max, even it becomes 10.1 Newton, it will start moving. It will exactly at Fs max equal to 10 Newton, it is ready to move but not moving. As you increases this by 0.1 Newton, 0.2 Newton, 0.3 Newton, it will have some acceleration. It will start moving. It will start moving beta. ठीक है? Now, always remember this 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 static friction force, that is, or max. I should write, most of the time people write like this, but actually this is Fs max. It is greater than Fk. Fk. Why it is there? Actually, what happens when block is not moving? Try to understand. Then interlocking is complete. And what is the state of the object or the block? It is at rest. You want to change its state. You want that this block at rest, it should start moving. So you are trying to change the state. So that's why you need a larger force. You have to overcome this interlocking. But when block is moving, then basically internal locking is not complete and it is moving, interlocking is taking place, but at the same time this block in its motion, it is overcome this interlocking. And due to inertia also, because now block is in motion, it want to continue its state of motion. It want to maintain its state of motion. So interlocking is not complete when block is moving. Okay? So that's why opposing force will be lesser as compared to the case when interlocking was complete. Okay? When interlocking, so interlocking is complete here in case of static friction, whereas interlocking is not so accurate, okay, in case of kinetic friction. So that's why this Fs max, it will be greater than Fk. So Fs max is how much? This is mu Sn, and it will be mu Kn. N will cancel out. So this mu S, it will be greater than mu K. So this relation you should remember. This is also, but remember this, you cannot say that static friction is greater than kinetic friction force. No, it's not always. It's not always, because static friction is variable. So that statement is not correct. But you can say maximum value of static friction force is always greater than this kinetic friction force. That is okay. So here try to understand when motion starts, so you are going to have this type of curve. If you further increase the force, then motion will, if you further increase this force, applied force, okay, if you are further increasing this applied force, then block will start moving in this region up to this. This block is at rest. So here block is at rest. So yeah, I can write in this region that this block is at rest. ठीक है ना, block is at rest. It's not moving. But here, if you further increase, block will start moving. Block will start moving. Yeah, block is moving. Block is moving in this region. And here you are having Fk. Fk, that is mu k into n, and this is called as kinetic friction. This is called as kinetic friction. So this is the plot in between. This is the plot between friction and applied force. Okay, friction and applied force. You also call it dynamic friction also. This is also known as dynamic friction. And this maximum friction force, Fs max, this is also known as limiting friction. You also going to call it as limiting friction. Friction. And this is also known as limiting friction beta. Is it okay up to this point? Hello?
Yes, sir.
Yes, sir.
Next is angle of friction. Next is angle of friction. Next is angle of friction. What is angle of friction? Suppose this is a block. You are applying a force over it. Okay? And this block is ready to move. So when this block is ready to move, in the case, then maximum static friction is going to act here, but I'm showing here. So I'm showing here. So I should write like this. So maximum static friction force is acting here, Fs max. Fs max. Other two forces which are acting, that is mg, and this is another one. ठीक है ना? That is normal reaction. That is normal reaction. If you make the free body diagram, I make the free body diagram of this. In free body diagram, this Fs max I can show here, Fs max, and here this is normal reaction. So resultant of the normal reaction and this Fs max is acting here. This is the resultant of normal reaction. This is the, and this F is acting here. Mg is acting here. So what is this Fr? Fr is the resultant of the normal reaction and static, ठीक है ना, static maximum value of static friction force. This is the net reaction on this, the net reaction force that is acting on the block. ठीक है, one reaction is this normal reaction, another is this friction force that is acting. So resultant of these two is Fr. Then the angle between this Fr, then the angle between this Fr and this normal reaction is called as angle of friction. So if you look at that diagram, then tan theta will be how much? This will be this side. So this side will be Fs max. How much is this side? If you look at this side, this is Fs max. This is how much? Fs max, max divided by normal reaction. So this will be mu s, and this will be n divided by n. So tan theta will be mu s. Tan theta will be equal to mu s. And theta, this theta, it is called as angle of friction. Tan inverse mu s. So this is called as angle of friction. So angle of friction, it is very useful. Many times you use this in the question. Okay, wherever actually when block is just ready to move, then this Fs max comes into the picture. So this type of situation, it will be very important. In which direction this net net reaction force is acting, that is important. So angle between the net reaction resultant of this Fs max and normal reaction, whatever angle it makes with the normal, that is called as angle of friction. That is called as angle of friction. Okay? So the angle between, you can write the angle between normal reaction n, the angle between the normal reaction n and the resultant of Fs max and n is called as angle of friction. Is called as angle of friction. Many times you use this in numericals. This is one of the angle. There is one more angle that is called as angle of repose. There is one more angle that is called as angle of repose. Next, angle of repose. That is angle of repose. Okay, try to understand. Angle of repose comes into the picture when motion of a block is taking place on an inclined surface. So here, suppose a block is placed here on this inclined surface, then in the downward direction, its weight is going to act. Its weight is going to act in the downward direction. This is mg. If this angle is theta, suppose, then I can resolve this mg perpendicular to this inclined surface. This will be mg cos theta. And along the inclined plane, there will be a component of mg. This will be mg sin theta. Mg sin theta. Now, due to this component of the weight, this block will try to move in the downward direction. When this block is trying to move in the downward direction, in that case, a static friction force will come into the picture that is going to stop, that will stop this block, that will stop this block to move in the downward direction. ठीक है ना? This static friction force, ठीक है ना, it will stop the block to move in the downward direction. ठीक है? Now can you tell me when this block will move, then when this block is going to move or will start to move in the downward direction? Can anyone? This block, I can write in the reverse way, will be at rest. Will be at rest on the inclined plane. On the inclined plane. When? Follow. When this mg sine theta up to the point when this downward force, this is less than or equal to Fs max. Fs max. So this block will not start moving unless and until this mg sine theta is less than this. Only if this mg sine theta is greater than Fs max, it will start moving. ठीक है ना? Block will start moving when this mg sine theta becomes greater than this limiting friction, greater than this Fs max. Now, from here, mg sine theta, it will be, how much it will be? This will be mu s into n, mu s into n. What will be n? N will be in this direction. So n is here. If you look at here, n will be equal to mg cos theta. N will be equal to mg cos theta. So substitute this n here. So this mg sin theta, it will be less than or equal to mu s, and this will be mg cos theta. So this mg here, m will cancel out, g will cancel out, bring this cos theta on this side. So this tan theta should be less than or equal to mu s. Mu s. So I can write this theta should be less than or equal to tan inverse mu s. ठीक है? If theta is less than this, then block will continue to be at rest. If this condition is satisfied, block will remain at rest. Will remain at rest. So if you want that this block should slide in the downward direction, ठीक है ना, for sliding, to start sliding, sliding, theta should be, yeah, for sliding, this theta should be greater than this tan inverse mu s. Mu s. That's why this theta, this tan inverse mu s, this is called as angle of repose. Tan inverse mu s, this is called as angle of repose. If this angle, ठीक है ना, this angle theta is less than angle of repose, block will be at rest. And if theta, slope angle, ठीक है ना, this is greater than tan inverse mu s, this block will slide in the downward direction. That's why this is important. This is called as angle of repose. So this was another important angle that is used in questions. Next, what will be the direction? How you are going to decide the direction of the friction force? Okay. Next is direction of friction force. Direction of friction force. Direction of friction force. So try to understand. Suppose this is one of the block, this is lower block. You apply a force over here. You are applying a force over here. And suppose this block is moving with some relative velocity with respect to the lower block. Suppose u is, what is u? U is the relative velocity of block 1 with respect to 2. So u is What is U here? U is relative velocity. Yeah, U is U is the velocity of m1, velocity of block 1, block 1 with respect to block 2, with respect to block 2. Block 2. So block 1 is moving with respect to block 2 in the forward direction. Though, then what is going to happen? If you look at this block, on this block, friction force, kinetic friction force, it is going to act in this direction. On the lower block, friction force will act in this direction. What I am saying here, this will be, ठीक है ना? On this block, it is moving in this direction, FK, FK. ठीक है ना? It is acting on in this direction. And for the lower block, it will be in the upward, like this. ठीक है ना? It will be like this. I will come to questions. ठीक है? It will be like this. So that is going to act. If you are applying force here, or you can say, even in this case, if this is so okay, ठीक है? It will be. Now suppose another case I will show you. Suppose both the blocks are moving together. Suppose both the blocks are moving together. ठीक है? You are applying the force here, and both combined block, they're moving as a. Then what is happening here? Here, when you are applying a force here, ठीक है ना? This block, what is happening? This block is trying to move in the forward direction. ठीक है? I don't know what is its speed. So I'm just saying both are moving together. So how they are moving together? Actually, when this block is trying to move in the forward direction on this block, a friction force or kinetic friction force is going to act in this direction. As a result, ठीक है ना? This block will move relative to the lower one. It will move in the backward direction. So it is going to have a friction force. Exactly equal friction force will be there. ठीक है ना? There, but because this block and this block, they are moving together, so this will be, no relative motion is between them. So I should modify this here, because there is no in first case there was relative motion, but here I'm saying both are moving together, so this will be static friction force. And here on this block, static friction force will be here. Suppose there is no friction, then suppose you assume the surface between them is smooth, then what will happen? This, due to this force, this block will move in the forward direction. So in which direction expected motion was? Expected motion was in this direction. So friction force will oppose this expected motion. So opposing the expected motion is in this direction. Fs is acting in this direction. ठीक है ना? Fs is, now this block is moving in this direction, so automatically with respect to the lower block, this block will move in this direction. So here this static friction force is going to act in the forward direction. This is Fs. Now how can you describe their together motion? For the low, this is m1, this is m2. So mass of the lower block is m2, acceleration is a, who is responsible? This F, minus opposing force is Fs. Fs. ठीक है? For the upper block, mass is m2, acceleration, mass is m1 for the upper block, m1. Acceleration is a, who is taking it in the forward direction? This is static friction. So this will be Fs. If you add these two, then you are going to have m1 plus m2 into a and that is going to be F, because Fs will cancel out by this. So what will be acceleration? That will be F upon m1 plus m2. So that's why these both the blocks in this way they are moving together. So who is responsible? Who is responsible that both the blocks can move in the forward direction? This is this static friction force that is acting in between these two blocks. So on the upper block, no force is acting, but still this static friction force, it carries this block in the forward direction. But it will happen only if this F is लेस देन, ठीक है ना? ये जो Fs है, this Fs स्टैटिक फ्रिक्शन फोर्स, ठीक है ना, that is less than maximum value of static friction force. It should be less, so it will be here. So what is more general rule to draw the direction of friction force? That is very simple. If no relative motion, first thing, no relative motion. If there is no relative motion, then you are going to apply Fs, static friction force. First thing, if relative motion is present, relative motion is taking place, is taking place, then you are going to use Fk, Fk. ठीक है? So whenever you want to apply, whenever you want to draw the direction of the friction force, what you have to think? Think, first assume the contact surface. Assume the contact surface, contact surface as smooth. Whenever you want to draw the direction, the simplest rule is consider that contact surface as a smooth surface. I'm just assuming. I'm writing assume. I'm not saying that is a smooth surface. That is a frictional surface, rough surface. Friction force will be there, but just assume that this is a smooth surface. So by assuming is smooth surface, think about the think about the expected motion. The expected motion of both the blocks. ठीक है? And whatever is the direction of motion of a block, in the opposite direction, friction force will act. Third, ठीक है? Apply, now apply friction force on each block opposite to their expected motion. Opposite to their expected motion. ठीक है? This will. So in this way, most of the time you can very easily you can apply the friction force. So here I have discussed most of the aspects of the friction force. ठीक है? Now we can easily solve the questions. So now I'm taking a break of 20 minutes, and again at 8:30 I will start the class. ठीक है ना? I will again start the class at 8:30. This is 8:10. So at 8:30 I will again start the class. and I will discuss some of the numericals, important examples related to this.
Okay.
Sir,